Thanks, Glenn, for the opportunity to speak to you today. I think I'm going to learn more from the presentations I listen to here than you'll probably learn from me. Yesterday when I was traveling here, and actually I represent just Ontario Ministry of Agriculture and Food, so I can't really speak for Quebec or for Manitoba or for any of the other provinces. But really there's not as much differences between Ontario and Ohio as what I originally would have thought. I drove here yesterday, took the back roads from Toledo and kind of got lost a little bit, saw a lot of farmland, and there's a lot of similarities. I didn't see a lot of big farms, and so as I go through this today, hopefully you'll see some, maybe a little bit different take on some of the things we do, hopefully some out-of-the-box thinking, and then if you've got questions you can ask me after. So just to go over a quick outline, just to start with agriculture in Ontario and just where are the differences, because there are obviously some. The issues around water quality, we talk a lot about source water and also about surface water, and surface water has gained a little bit more momentum because of the phosphorus in the Great Lakes, where the source water started out more of as a nitrogen issue for drinking water. We'll talk a little bit about manure, winter manure application, and it's just as much of a problem in Ontario as it is here, I think. And then just some of the ideas that farmers have had in moving ahead and trying to do a better job. And I always like to look at the winter application issue as, let's not focus so much on spreading in the winter as trying to find alternative solutions for doing more application during the growing season. And so I'm going to spend quite a bit of time on that. This is a picture from not too far from where I live. You can see that there's a lot more wheat. Now, when I came just off of the road at south of Toledo, there was a lot of wheat fields there. But then as I got closer to here, there was less and less.
Cover crops instead of wheat.
Yeah, I saw one sign that said, how did it say? Proud to be standing or something, a sign that talked about cover crops in the field. I saw some controlled drainage and some strip till, so it was a lot of the same kind of things. But there is a lot of the province that's fairly hilly, and that's different than what you've got here. Having said that, there's also a lot of area around Windsor, Chatham, up towards London, and then in Perth County around Stratford, where we've got a lot of the same type of flat land, heavy clay soils, and then some of the same issues that you've got. But I think generally we have more wheat in our rotation than you do. Similar to you, we've got a large urban influence. There's only about 2% farms. The rest is urban. And 20% of the farms produce 80% of the commodities, which is probably similar to here. Our manure storages are probably smaller in general than yours. We don't have very many lagoons. The dairies are quite a bit smaller because they have quota and can't afford thousands of cows. The biggest dairy is actually just a couple of kilometers from where I live, and they milk between 1,000 and 1,200 cows. But for generally, most of the herds are in that 100 to 200 cow range. Manure composition is a little bit different. I think we have thicker manure. We have more nutrients. I would never hear of a dairy farm being able to apply 12,000 gallons of manure. Generally, in that 8 to 10,000 would be the maximum. Probably more often 6 to 8. Same with hog manure. Finisher manures tends to be a little bit higher composition. So our application rates are also a little bit lower. And I haven't heard a lot of talk about municipal organic amendments, but because we've got quite a bit of an urban population, there is a lot of organic amendments coming from compost, coming from biosolids pellets. We get a lot from Detroit. And compost and different biosolid processed products. So we do have nutrient management regulations. They're just as complicated as Ohio's, from what I can tell. From what I can tell in Ohio, you've got your nutrient management regulations for CAFOs, for other farms. Then you've got your Western Basin regulations, and then you've got your Mary Lake regulations that are the most intense. It's kind of the same for us. Any farm that has over 300 nutrient units has to have a nutrient management plan. Any farms in source water protection areas. So source water protection areas means that they have water coming on their farm that goes to the groundwater, within 2 years gets to the well. And if they've got a 2-year time of travel to the well, they're in a source water protected area, usually just for municipal drinking water, and they have to have a nutrient management plan. And they're really restricted on what they can do. Any farm that needs a building permit or is expanding their storage and needs a building permit, they need a nutrient management strategy. When they do a strategy, they do a plan, but there's not really any follow-up on making sure that they follow those regulations. Nutrient management plans in general have been a look forward to 5 years. Make sure you've got the land base, make sure you have enough space and storage for that manure. There are phosphorus and nitrogen application limits. Generally, we're allowed to put 70 pounds over crop removal. Basically, that means we can increase our soil test for phosphorus by 2 parts per million. As those phosphorus soil fertility levels get higher, that recommendation is frowned upon. And a maximum of 200 pounds of nitrogen. That's if the crop doesn't require it. If the production recommendations say you need 220 pounds of nitrogen for your corn, it's all good to go. But if you had a soybean field and you were putting 200 pounds of nitrogen on it, first of all, you'd probably have a flat crop, but that's not part of the recommendations. And then separation distance from water sources, especially with the biosolids and some of the non-egg source materials. And then we have restricted winter application, although who's restricted and what each person is allowed to do is a pretty big range. And we'll talk a little bit about that. So just to start on the water quality issues, we have the same kind of erosion problems as you do. Where we've got topography, we've got a lot more rill gully type erosion. In the flatter areas, it's more sheet erosion and smaller rills. But one of the things that I've noticed is when we get a rainstorm, especially, well, I guess it doesn't matter, when you're standing outside and watching it, it's only a couple of seconds with those thunderstorms where you start seeing the water just going over the surface. It's not infiltrating, it's just moving across the surface. And so that infiltration capacity has really been reduced, at least in our soils, over the past few decades. And the impact of poorly structured soils is really starting to show. So we have more runoff potential, and with that runoff comes the potential to lose phosphorus. And most of that phosphorus is going to be high in particulate phosphorus, especially if we already have high fertility levels on those fields. This is a picture of a field of a hog farm. Needless to say, they just put manure on, and there's quite a bit of phosphorus that's going to be in that water. And then again, on hills, and this is a field that's been abused. This field gets soybeans almost every year. It gets plowed. It's just, I don't know, some people don't really care about their soil too much. And as a result, they don't have very good yields or very good emergence. One of the things that we try to promote is 30% cover 100% of the time. And that's part of our conservation strategy. It doesn't matter how they do it, whether it's with cover crops or with residue, but we try and encourage 30% cover 100% of the time. Sometimes, though, the power of water is amazing. And so this field probably had 70 or 80% residue cover when it was planted. We had a pretty big rainstorm, and most of it was on top of that culvert and through the ditches. So the power of water is immense, and it can take, in this case, it took a lot of the residue with it. It could probably have taken that much soil as well. And then we've got this material called snert. You probably have it here too. Soil on top of snow. We did some measurements of it, and the snert had 9.5% soil organic matter, phosphorus of 42 parts per million, which ours is Olsen. So if you almost have to double it to get your Bray. And then the potash is 208. But the rest of the field, 3.2 organic matter, 11 for phosphorus, and 80 for potash. So the best soil is being lost. The highest fertility, the highest organic matter is being lost off the field in those wind and water events. So organic matter decline is part of what's leading to the aggregate stability, decreased aggregate stability, which increases the erosion. We've got decreased water holding capacity, so you sometimes see that in droughtier corn when you get a dry period. More flooding in areas that just can't infiltrate quick enough. And then you can see in here we've got areas where you've got quite a bit of emergence and poor stands and just corn that didn't have enough water. We were lucky. One of the labs that I work with gave us the organic matter from all their soil tests that they'd done from 2002 to 2018 by county. And so we processed that data, and there's a lot of data. I'm just going to show you one thing, though. This blue line represents the change in organic matter across all of Ontario. So every soil type, whether it's sand, silt, clay, livestock, non-livestock, represents everything. And you can see there's a decline over that time. And this dotted line is the average of all the soil tests over that period. This red line, it represents Lambton, Kent, and Essex. So it would be the soils that are most closely to Ohio. It's the part of the province that, or the part of Ontario that has less livestock. It's got mostly corn, soybeans, and more often corn, soybeans, soybeans, and sometimes corn, soybeans, soybeans, soybeans. And so over time has lost quite a bit of organic matter. And so you can see that the decline there is much higher than what we have across all of Ontario. And this represents over 300,000 samples. We had some more added last year. But it tells us a story. It tells us that in these areas where we don't have the livestock, where we have a rotation that's not putting as much carbon back as what the soil requires to maintain those organic matter levels, that we have to be looking at other sources of carbon. And whether that's organic amendments or whether that's cover crops or a combination of both, it's going to be important moving forward. So that decline represents about a 0.7% decline in organic matter, which represents about 150 pounds per acre less organic matter. So a reduction in water holding capacity, reduced infiltration, and then reduced aggregate stability. And there's some research that's been done to look at what kind of rotation will add enough carbon that we can sustain our organic matter levels. And it depends on a lot of different factors, but generally there's been a couple different types of research that would say that corn, soybeans, you can't maintain your organic matter level. If you've got corn, soybean, wheat, or corn, soybean, wheat with red clover, we start seeing an increase in that potential, an increase in that carbon coming back. And if we've got alfalfa in that rotation or a perennial forage, it's that much quicker. So it just gives an idea of what kind of rotations and what maybe we need to do to start increasing the amount of carbon that's coming back. And I think I've heard that same message from quite a few speakers in the States. So from an Ontario perspective, what's different? And probably some of the same things are happening here. First of all, there's a change in livestock density. It doesn't mean that we don't have parts of the province that have a lot of livestock, but generally we don't have the same number of farms. Some of them might have been small farms before. Now there's maybe just as much livestock, but concentrated in different areas. And so we've got more land that doesn't have forages in the rotation anymore and doesn't get the manure back. So those are two big ones. The other thing, we have a lot more land that's rented now than owned. So you can see in this picture, actually I should go back to the last one. So everything that's yellow was crops. This is in 1995, 2011. So you can see that the red is livestock. So there's quite a few livestock farms in 1995. That same watershed, 2011, quite a bit less. The rented land is represented in red. Quite a bit more owned in 1995. 2011, a lot more of that's rented. And we start to see that in all over the province. And one of the things that's maybe don't have research numbers, but generally people take better care of land they own than land they rent, especially if they don't know how long they're going to have that land. This is, I don't have all the details on this one, but what this slide shows is the purple dots are the pig farms in Lambton County, which is Petrolia, Sarnia, that area. And then this is in 2008. The yellow is the wheat that's being grown. Here in 2013, we've got a lot less wheat. Now, I don't know how accurate that is. There is less wheat being grown. That we do know. This year, after we had the difficult spring and fall the previous year, there's a lot more wheat again because people don't, especially on the heavy clay soils, don't want to have to plant all their acres, 100% of their acres, in a wet April, May, June, some cases July last year. So they want to spread out their workload and have a little bit more wheat in the rotation. The other thing, impact of field size and crop rotation. 1955, you had 20 small fields in this area. 1975, it was 13 fields. Fence rows were removed. 1999, they'd added random drainage tiling to that field. And in 2013, one field, one crop, systematic drainage. If water's going to move and there's no fence rows to slow it down, it makes sense that we're going to get more erosion, less infiltration. So this is just there was a similar slide shown in the presentation this morning, but if we look at the monthly precipitation, this is over 3 years, so from October to September, it's a cocoa rose information, but you can see that it varies. It varies when the rainfall is most intense, but you can see that a lot of rain happens in the non-growing season. In 2016, 2017, those were the months that had the highest rainfall. The other 2 years, quite a bit in October, November, quite a bit in April, May, and July, but quite a bit of water that happens during the non-growing season. And so some of the issues around source water is leaching, the downward movement of nutrients with water in the soil. We always talked about it as being a nitrogen issue, nitrate, the ammonia nitrogen from manure converts to nitrate, moves below that root zone, and potentially can get into the groundwater. But we've also got that issue with phosphorus more and more. And in Ontario, we've got high calcium soils, so we use the Olsen soil test because of that. We also don't have as deep a soils as you have. Most of our topsoil is in that 6 to 8 to 10 inches, depending on where you are. We don't have these nice 2 foot profiles of topsoil. But when we get to about 35 parts per million of phosphorus in our soil test, we start getting more of that phosphorus coming through tiles. So the soil particles can't hold any more of the phosphorus, and it starts moving. And so we get 2 different methods of some of the phosphorus and nitrogen moving. One is through that matrix flow. The other is through worm channels or through macropore flow. And this is just an example of macropore flow. We've got a macropore that's broken because it's been pre-tilled. We've got another one where the macropore goes right to the surface. We apply a layer of manure, and where that macropore goes right to the surface, that manure can go through that macropore. And if it happens to intersect into a tile, then we can get some of the nutrients going into that tile. And this picture at the top, this is a study that we did looking at injection of manure at side dress time. And it took 7 minutes for the manure to get from the surface to the tile. And you can see that it did quite a bit of contamination. So if the rate's high enough, if the soils are wet enough, the manure can get to the tile quite easily. Generally, if the rates are less than 3,500 gallons, we don't see that as an issue. So non-growing season phosphorus loss, I think I heard the same thing this morning. 80% of the phosphorus loss can occur during the winter period, during the non-growing season. So it's a higher risk for agricultural phosphorus loss. and intense rainfall. It seems like we've been getting more intense rainfalls. It also seems like we're getting more, it snows, then it melts with the rain, and we just get a lot of water moving. And I'm sure these studies have been done in Ohio as well. We actually get quite a bit of information from King. What's his first name? Kevin King, and others. Here is 3 different watersheds that they did the measurements. Essex is flat, heavy clay. Thames is kind of in the middle. Maitland is quite hilly. And you can see that the light blue represents this is the total phosphorus in the tile, total phosphorus that ran over the surface through particulate, through surface water. Highest on the flat land, but we have more phosphorus in the tile, but less of it in the tile. So it gives an idea of how landscape affects the amount and the process that phosphorus goes through. The red line represents the surface water quality control goal. Needless to say, we're over it regardless of which study site we were at. And manure on frozen and snow-covered soil. How many people have seen this before, talked to the farmer and they said, oh, this is no problem. It's just solid manure. It's not going to go anywhere. What about this? Or this? So this was taken, manure was applied on snow ahead of forecast rain that was going to be more than an inch. Solid manure, and the neighboring farmer, he was livid, so he took pictures. Anybody want to drink this water? Anybody want to guess how much phosphorus would be in it? A lot. This is why we don't want manure on snow. Because phosphorus in a winter landscape, there's just nowhere for it to go. If we've got frozen soil and then we get a thaw with some rain, we've basically got the water and the snow taking the path of least resistance. And it's going to take some of that thawed little bit of soil at the surface with it. And when I look at our nutrient management regulations or BMPs, we always look at what is the hydrologic soil group. So is it a sand, is it a loam, is it a heavy clay? And then what is the slope? And that gives us an idea of what is our potential runoff. So needless to say, heavy clay soil with slope is going to have the highest runoff potential. Well, if we have liquid loading that says when we have a high runoff potential, the most we should surface apply is under 5,000 gallons. Now these are imperial gallons, so you have to multiply them by 1.2 to get US gallons. But 5,000 gallons, less than that, if there's no infiltration capacity, that means regardless of what soil type you've got, it's going to be high runoff potential. And that represents about 5 millimeters of rain, which is about 1/8 of an inch. So if I spread manure, solid manure, the kind that different people have told me, it's just straw, there's no nutrients in it, those nutrients aren't going anywhere. Well, if I have beef manure at 10 tons, I've got approximately 170 pounds of total phosphorus. That's not available, that's the phosphorus that's in that manure. That phosphorus mixed with that 5 millimeters of rain is going to have nutrients. If I have biosolids pellets, processed biosolids, 3 tons per acre, I'm looking at closer to 300 pounds. And yet those biosolids pellets are being applied in winter all the time, because it's a fertilizer, and so it doesn't fall under the manure. So some of these issues have made that agreement, the Great Lakes Water Quality Agreement, which I'm sure you've all heard about. So I'm not going to go through the details, except to say that in Ontario, the Thames River and Leamington tributaries are the priorities, and we have a target that we have to reduce that phosphorus by 40%, 20% by 2020. And it all depends on what kind of weather we get, whether we can do it. So the potential nutrient losses, we've already talked a lot about some of these today. But for nitrogen, the losses from manure are ammonium volatilization, so the ammonium portion that doesn't get incorporated, that dissipates into the air. Nitrate leaching, so ammonium that converts to nitrate and moves to the soil. And then nitrogen loss either through surface runoff or preferential flow. For phosphorus, the main losses are particulate phosphorus through soil erosion, phosphorus that's tied to the soil, soluble phosphorus through the runoff, and then soluble and particulate phosphorus that goes through tile, and then the leaching when the soil test is very high. With manure application, that phosphorus occurs, well, it results in the algae blooms and poor water quality. And I heard a comment this morning where they said that manure is the biggest culprit. Definitely the general public thinks manure is the biggest culprit. And then the phosphorus application during the non-growing season is considered the highest risk. When we have the combination of high phosphorus and highly erodible soils, that risk of phosphorus getting into the water is higher. Where we can incorporate the material, especially in the fall after corn harvest, if we can incorporate it going into the winter, we tend to have a lot less loss. And that was some of the studies that was done in Wisconsin a couple years ago that they reported at the Manure Expo, where if you've got tilled soil, if you have to winter apply, it's better to do it on early in the winter season, like December, and in tilled soil as compared to just surface applied on no-till. And then winter surface application on frozen soils is definitely a high risk, definitely not encouraged. So the BMPs, we've heard these probably a lot of times, right rate. So the right rate, uniform application, frequent analysis, including pH. I'll talk about that a bit later. Calibrate the equipment so that we can apply the rate that we think we're applying and the rate that's going to match some of the crop needs. Right application timing, apply in spring or into growing crops wherever we can. So instead of focusing on everything, getting the corn harvest done on time and getting our manure on those acres or getting them on before we plant, let's try and focus more on growing season. After cereal harvest, we can put it on with a cover crop. After corn harvest, where manure can be incorporated. Right field, which field needs the nutrients the most? Pretty sure that the field beside the manure storage doesn't need it. It's the easiest one, but it probably doesn't need it. And then ensure, although that's not always possible, field conditions maximize infiltration, minimize runoff, wherever possible. Right place, rapid incorporation or injection to minimize ammonium volatilization, and then avoiding concentrated deep placement that's that much closer to the tile. And then I've added a 1R, right storage management. So permanent cover to help eliminate storage losses, runoff management for temporary field storage. Do you have temporary field storage here?
Yeah, we have. You're thinking of like frac tanks type thing?
No more, just piles in the field. Stockpiles where there's no tile drain and you go through a whole list of how many days can you store it. That's what I mean by proper management.
A lot more than we thought after this last winter.
Yeah, definitely more than we thought too. And yet it's encouraging to see more of that stockpiling because it means that that's manure that's not being applied in the winter. So I'm not going to go through this, but the Ontario-Ohio winter application comparison, yeah, there's different things in different boxes, but when it comes right down to it, we're not as different as I thought. You can apply in the winter to a growing crop or to 30% residue. You can apply it if you can incorporate it the same day. We don't have the saturation restrictions, but let's be real. If you're going to get stuck, it's probably too wet. And nobody wants to do compaction if they're only going to do that if it's absolute emergency and if the pit is going to overflow into the river, well then you have a contingency plan that you have to do. And this is just an example of, in 2017, we started recording where winter application was happening. This is in the Lake Erie, the watersheds that drain into Lake Erie, and you can see there's quite a few. Even though we're trying to recommend people don't apply in winter, approximately 25 formal complaints to the Ministry of the Environment, and most of these the Ministry of the Environment can't really go to because they're not regulated not applying the winter. I told you before that there's a whole bunch of different regulations, and so nobody knows who fits into what. That happens here. But as a result of that, there's a group that's working together with commodity organizations, and the group is called Timing Matters, Responsible Manure Application. It's being run through the commodity organizations with Farm and Food Care, and it's a targeted effort to try and reduce winter application. So Timing Matters is an Ontario initiative between farm organizations, OMAFRA, and the Farm and Food Care to promote optimal timing of manure application throughout the year. So it's not just winter. During the summer, we're trying to get people to plan ahead. Getting a better understanding of manure value, storage options, application equipment, and timing. And basically, they're promoting that manure planning is a 12-month job. It's not something you do as soon as the pit starts getting a foot from the top, because then all of a sudden, the options are limited. So it's raising awareness of manure application timing concerns, looking at explaining the risks to people where manure is being applied to frozen ground, and then trying to look at other alternatives. And there's going to be different alternatives for different areas. This is an example of some of the mapping that they're doing now, and when they record, the person, the representative from that commodity organization goes to that farm and basically interviews them and asks them, so what is the reason that you're doing winter application? And in some cases, their pits are full, they don't have enough storage, or they haven't planned well enough the storage that they have. After last year and the year before, we've had wet springs and wet falls. Some people just didn't get their corn off in time, and they have no choice but to apply in the most safe spot. Other people, they just say, I have time now. The ground's frozen, so I'm not causing compaction damage. It's not a big deal. It's just solid manure. And so there's an education that happens there. And then some people just, they do it because their parents did it before them and their parents did it before them. So some of the misconceptions: good way to reduce compaction and ruts. Solid manure holds its nutrients. It doesn't dissolve in water. Yard scrapings are just bedding, therefore the precautions don't apply. Long rotation, long tradition of winter application, it wasn't a problem before, why is it a problem now? So those are some of the misconceptions that we're trying to change. And then a little bit of awareness around just the late winter frost when everything's frozen and there's just no capacity for infiltration. And Bruce Kelly likes to call it winter concrete. And then they've started a Twitter, Timing Matters, and every couple of days or weeks, depending on time of year, they'll have a Twitter message that says science is in, nutrient supply to frozen ground will run. They've got a whole bunch of them that they just try and remind people to plan about manure application. And then some of the written material, some of the articles that get written for the commodity organizations or for local press. So a lot of what we're looking at with nutrient management, and I'm really excited about this because 4R started in Ohio, and Ontario's been copying. We learn a lot from Ohio. And so one of the things that I dream is going to happen someday is that nutrient manure regulations are going to be a thing of the past if people voluntarily go with the retail 4R. So in other words, if they're working with their retail, the consultants, to work the manure into the 4R nutrient plan that they have at retail, then hopefully that's going to be better than what we're doing now. It's going to take a long time. It's not going to be perfect, but it's probably going to mean better nutrient application to the rates that the crop requires. One of the things with our manure application is that we recommend that manure rates get applied based on P needs, based on phosphorus needs, not nitrogen, because we would be over-applying that phosphorus. So we generally recommend 2/3 of the manure application to meet the core nitrogen needs. The rest should come from commercial nitrogen. And that way we're not over-applying the phosphorus. And most of our dairy farms especially phosphorus soil tests on dairy farms is pretty low. It's the pig farms and the poultry farms that have the really high phosphorus levels. So some of the things that we're trying to promote is trying to get healthier soil that will do better infiltration, soil that's got more organic matter, that does better nutrient cycling, using more organic amendments and cover crops for non-livestock farms. But we're also looking at management practices for protecting water that looks at the phosphorus index, that looks at timing as a way of reducing that loss. And I think the key thing is to do a better job of valuing manure, kind of like what you were doing in your last presentation on the poultry litter. I'm not going to spend much time on this one except to say that soil fertilization has two different philosophies in Ontario. We either have the recommendation where you're just sustaining what you've got, basically sufficient for the crop that you're growing this year. So that means if you're renting land and you don't know if you're going to have it next year, here's the minimum amount that you're going to get your optimum yield. And then the other one is a build and maintain. And this is one that a lot of people like to do. They've got low phosphorus soil tests. They want to build it until it gets to a level that they like, because then they've got enough there, and if it gets expensive, they can reduce it, whatever. But the ideal range for us, using the sodium bicarb or the Olsen method, is between 15 and 20 parts per million. Anything over 60 is considered very high. Anything under 9 is considered very low. So it's a totally different scale than what was shown in the previous presentation. And you can see, based on the calibration for the soil test, for the Olsen test, once you get to that 20 parts per million, you've basically maxed out the amount that you're going to need for that particular crop. But if we've got soil test levels that get higher, once we get to this line is the environmental threshold value, and you can see that this curve is the level at which you start getting increased phosphorus going through the soil, out the tile, matrix flow, or P leaching. And so you can see that once we get to that somewhere around 30, 40, we start getting an increase in that amount of phosphorus that the soil can't hold. With the runoff phosphorus, basically it's a straight line almost, 0.1. So once we get again to that 30, 40, we start losing a lot more of that phosphorus. So generally we try and promote that if you're going to, if you've got a soil test level that's less than 20, yeah, you're in a buildup, you probably want to get to that level. You want to maintain, but once we get more than 25 parts per million, we don't want to be building it more, because we're just increasing that environmental risk. And so part of what we're trying to educate farmers is we're not trying to get that 30, 40, 50. And where we've got livestock farms that are at those levels, maybe we need to think of some alternative strategies, and we'll talk about that in a minute. So how and where does the 4R fit into manure BMPs? Well, first of all, when we've got livestock, there's a couple of things in addition to just the crop questions that we need to ask. How much manure is produced? How much storage is available? How many acres will the manure be applied to? What is my crop rotation? Where does manure fit into the places in that rotation? And can I apply that manure that's produced to the crops I want it to using the 4R standards? And so really what it comes down to, better planning to find opportunities to apply more often during that growing season. And so most of the fields still need commercial fertilizer. In most cases, we're putting down manure based on phosphorus rate. We still need, especially for a corn crop, soybeans, that's not the case. But for wheat and for corn, we are still going to need some commercial nitrogen. Usually put on as a starter, and then potentially, depending on the weather, also put on as a side dress application, commercial usually. Nutrient management plan information often is not shared by the person that prepares the nutrient management plan for the livestock farm and the retail that they're buying their fertilizer from. Wouldn't it be nice if the guy behind the counter had an idea of what the manure analysis told them was in that test, and if that information was shared? And it's probably just a communication issue, but it's something that does happen. For our retail, the role is to try and increase the number of acres that they can report saying these acres have been managed using 4R standards, because then the government might use the carrot instead of the stick and might not make regulations on phosphorus management or phosphorus applications. So 4R retail can provide some additional services to livestock farms to improve that management, both in getting that testing done for the analysis, because how many of you here do a manure analysis regularly that have livestock? It's about the same number in Ontario. I bought some manure from my neighbor. I asked him for a long time, can I buy some manure? Can I buy some? Finally, he said yes. He bought my straw. And he had never, ever taken a manure analysis. He's a progressive farmer. It's like, really? Anyway, I was shocked. We took one for him. And he was surprised at how much nutrients was in that manure. So I think there's an opportunity for a lot more of that communication between retail and nutrient management consultants and farmers. And ideally, nutrients are going to be treated as nutrients. So regardless of whether you've got manure or whether you've got commercial fertilizer or whether you've got biosolids or whether you've got compost, the nutrients in those materials are going to be treated the same. Livestock farmers now, in a lot of cases, think they're being picked on because of the regulations, because of the scrutiny that they get. But really, a nutrient is a nutrient is a nutrient, regardless of what form it's in. And if we do this right, we have the opportunity to provide positive messaging for those sustainability platforms. So for Walmart, for Costco that's buying some of the produce from certain organizations or farms, if we can say, yes, our nutrients are being managed properly, including manure nutrients, that goes a long way. Application standards, some of them that can include phosphorus index risk assessment, two of the application standards. Now, in Ohio, these ones might be a little bit different, but one of the application standards in Ontario, if you apply phosphorus to an alfalfa field after harvest because the phosphorus levels are low, well, 4R says that's the wrong placement. You shouldn't be surface applying it. But with a forage, it's pretty hard to incorporate it. So the way that they got around that is they said, okay, surface application is fine as long as you've got a phosphorus loss assessment risk that says it's low risk. And generally during the summer, if you've got a standing crop and you've got dry weather conditions, the risk is very low. And then record keeping at the same, looking at time, looking at map, looking at weather, and phosphorus loss risk is in there as well. Then there's also the record keeping standards. Basically, have the nutrients from manure been accounted for? Have we maintained the setbacks in sensitive areas? Have we documented those sensitive areas? And are all the nutrient sources being accounted for, including the nitrogen credit from legumes, the nutrient credits from manure, from biosolids, etc. So those are parts of that 4R that fit manure into the same as the commercial fertilizer. And so we have some tools, and I just want to spend a few minutes on tools. The manure organic amendment calculator is probably something that would work in Ohio just as well as it does in Ontario. But we've got nutrient management software, and it's gotten pretty complicated. It's what the nutrient management consultants use to do nutrient management plans. And so we have to do it over because the Microsoft isn't supporting the platform it's on. So we're doing it in calculator one-offs, and then eventually putting those calculators together to do the full nutrient plan. And so what we have is 3 different calculators: crop nutrient calculator, organic amendment calculator, and a fertilizer calculator. And next week we're going to have hopefully next week or 2 weeks from now, we'll have a phosphorus risk assessment tool. So it's an app that you can use on the phone, on the computer, on a tablet, English or French, sorry, not Spanish. Metric, imperial, and US units that you can change on the go. So, and then it's got Ontario data, but when it comes to the manure analysis, I don't know how much different that's going to be. So the crop nutrient calculator gives you the nutrient needs, NPK needs, based on location, yield goal. And then it also gives your crop removal. And crop removal is not going to be that much different in the US versus Ontario. We've got the organic amendment calculator that gives us the available NPK and value after application, as well as micronutrients if we've included them, that are applied from the manure or organic amendments. And then a fertilizer calculator that blends fertilizer sources to achieve the target rates. So if we know that this is how much we're applying from manure, we can add NPK, and here's the amount we need. So just a really quick, this is the crop nutrient calculator. It gives the production recommendations. It gives the nutrient removal based on our location, based on our yield goal, based on our soil test levels. And then it also gives us the nitrogen recommendation calculator. So basically, how much are we taking off because we're using manure as our nitrogen source? Because we've got high heat units versus not as high heat units in the north, how much nitrogen are we adding or subtracting? How much are we adding or subtracting because of soil texture, and when are we applying it? So it's the nitrogen calculator that gets used all the time in our crop production, embedded. The manure calculator basically lets you choose from either a database of over 15,000 samples by livestock type and by dry matter range. And you can choose from the data bank, or you can put your own analysis in. If you put your own analysis in, it gives you an idea of how you compare to that database. And it lets you put on micros as well. So and then we've got the management part of it. When is it applied? What rate is it applied at? How quickly is it incorporated? What season is it applied at? And that gives us an idea of what will be the available nutrients. So the available nutrients on a per ton basis, and then based on our application rate, the available nutrients. And then it gives us the ammonium versus the organic nitrogen index loss if we applied over winter. Phosphorus, how much is available right away versus how much is available from that application. Trace elements, organic matter, gives us that same idea of what are we applying. And then it gives us a value after application. Eventually, people will be able to put their own numbers in. But to get this out quickly, we've defaulted some numbers. And it's pretty high fertilizer values because they forgot to put in the new ones. The phosphorus loss assessment tool is basically looking at what is the risk on a per site basis. So if I've got topography or if I've got a flat field, that's going to change my inputs. And so just to give you an idea of the things that go into this tool behind the scenes, so it's very complicated even though it looks easy on the screen. We look at soil erosion, so from the USLE, in your case it would be Russell probably that would give you that information, and that's what Kevin's been using. Soil test, what is the crop type, what is the hydrologic soil group, so is it a sand, is it a loam, is it a clay, how much buffer do we have if we've got a water course right beside us. Local precipitation just automatically appears. Tile drainage, do we have a tile drainage system? Is it systematic? Is it random? Is there none? And what is the average tile spacing? What is our application method of nutrients, both commercial fertilizer and manure? When is it that fertilizer or manure applied, and at what rate? That gives us the phosphorus risk assessment, both from just the field characteristics and then also from what's applied. And that gives us a final number, which is put on a code, and so anything less than 60 is low, or sorry, very low. So there's not a number, it's more of a zone that gives an idea of how safe we are. So I'm not going to go through that in very much detail. I put that there so if anybody's looking at the notes afterwards. But we have ag maps, which has layers of maps. We can look at the erosion and get an idea of what is our erosion rate per year, where each pixel is based on a 10 by 10 estimate for erosion based on topography, soil type, and rain. Now, if I do that, this is an example of a field with some topography, corn, fall plowed, 11.5 tons per acre per year erosion. Red is the highest, green is the lowest. If we go to a corn, soybean, wheat rotation with strip till or no till, suddenly we've reduced our erosion potential to about 1.1 ton per acre. So it's a kind of a neat tool, similar to what Russell will do, but embedded in this calculator. or we can just put in our slope, we can put in our crop type, and it will do it automatically for us, not quite as accurately. And that gives us a particulate P from surface runoff, dissolved P from surface runoff, and then what can go through the tile. And it just gives us an estimate based on our characteristics. Then we put in our application, whether it's fertilizer with a whole bunch of different blends that we can choose from, or whether it's manure, and we can get an idea of what is the risk. So for example, here it's late fall surface applied, and you can see that I've got a pretty high phosphorus risk index, where if I use that same manure but I spring inject it, I've got a much lower. So I go from 189 to 3.2. Just another calculator. This has nothing to do with manure, but this is a calculator that you can take a picture of crop residue and get an idea of how much residue is there. And it keeps records of fields and by year. So it's, I just put it here in case anybody wants to look at it. Basically, you take your picture, you select your colors, and then the intensity of the colors, and it gives you a percentage. So it's pretty easy. Not 100. You got to practice. It's not 100% accurate, but it's a pretty cool tool. It's a lot easier than a residue rope. That's the nice thing about having a daughter that does programming. So farmers preventing N and P loss. This is just a couple of ideas outside the box. And I really like this piece of technology. It's European technology. It's called a dribble bar by Vogelzang. It allows us to put manure on growing crops in different times. So we can put it on spring application on winter wheat. We can put manure on after planting corn, after hay harvest, after wheat with cover crops, and there's other opportunities as well. Canola, soybeans. Some people will do it, not that much, but the nice thing about this is it's on a bar that's similar to a sprayer, and so if I look at in some of the injection technology, it's going to take a lot of horsepower. It's going to take time. Here, if we've got a canopy and we can lay down the manure underneath the canopy, reduces the odor. You've got narrow 10-inch spacing, so it's uniform application at lower rates, and it does a nice job. It's not the answer to everything, but we can get a lot of manure applied. It can be on a drag hose. It can be on a tanker. Some people have taken that idea and have modified that equipment. This is a custom applicator just north of London who is doing that same type of application into standing cover crops. One of the things that with variable rate is really difficult, because if our application rate is based on phosphorus, then we're generally going to have one application rate pretty well. So is there an opportunity to incorporate some commercial fertilizer into liquid manure so that we can just save a pass and inject it based on nitrogen needs? Or there's some new technology, Harvest 3000, that's helping with flow units and with measurements, is helping to put some of that nutrient on at a constant rate. One of the things that we learned by accident, pig manure, not dairy manure so much, we can skim off the top. We have very low phosphorus but high ammonia in that manure. You can put that on the fields that are closer to the farm that are being planted to corn. Some of the more solid nutrients take farther from the storage. That doesn't work with dairy manure, and it's tricky to know when that phosphorus suddenly gets higher. It means testing, but it is an idea that some people have tried to do. Strip till and manure application, I think once we figure this one out, it's going to be pretty cool. If we can incorporate some of that manure in the fall, come back and plant into those strips in the spring, then we've applied that manure, we've incorporated it, and we might have to come back with some starter, or maybe some inject, but we're doing a better job of 4R in that scenario. Biocrops, I think, has some opportunity, although so far not a lot has been done yet. Oilseed radish, with cereal rye, and then you plant the corn into that oilseed radish that didn't overwinter. And it's worked in a couple fields. Compaction from spring application. This is actually a field that was totally compacted last spring. Didn't look pretty all year. It was right along the 401, so everybody can see it. But what does it cost in the long term? And is there some way that we can look at maybe application a little bit differently? And so we can look at tire selection to minimize the footprint. There's going to be at the Manure Expo in Ontario this coming summer quite an emphasis on compaction and some of the solutions. Do we have enough land base that we can stay off our wettest fields, our heaviest clay fields, and maybe go to the lighter fields? Tile drainage to eliminate the 80-20. Self-inflation tire systems are becoming a little bit more popular. But what does it cost us? And this is information that I stole from Ohio. Scott Shear, is he at this facility? This is cool stuff. He was presenting at, I think, Southwest Ag Conference in Ontario a couple years ago. And he talked about compaction from different machines. And he did some testing with manure applicators. 45% of the field was trafficked. So needless to say, it wasn't wide application. Where he had normal soil conditions, there was basically 6 bushel difference between the trafficked area of the field and the rest of the field. Where it was wet, he had a 27 bushel per acre difference in that tracked area versus the normal area. So if I take that one step farther and I say, okay, if you've got 27 bushels per acre yield loss of 45% of your field, and your corn is worth $4.50 Canadian a bushel, that works out to about $50 per acre on compaction loss. It's not something you see easily, but if that's the case, then what is the opportunity to put wheat in our rotation, put that $50 savings towards our wheat, and then also have the opportunity for cover crops and for some manure application. And another method of just valuing the resource a bit is thinking about manure a little bit differently. And I've heard a couple people talk about it, including Glenn. So if I have 1.3 million finisher hog operation, 2,000 finishing hogs, 1 year open liquid manure pit, so I've got about 1.13 million gallons, so that's about 1.56 US gallons. Well, if I convert those nutrients, those available nutrients, to urea, MAP, and 0060, I have about $71,000 worth of crop available NPK. So if I'm putting manure on in winter, would I put those nutrients on in winter if it was from retail? Would I pay for it? Probably not. And do the fields that I'm applying those nutrients to need it? So again, it's emphasizing the value, and that's been done a couple times already today, where just looking at what are the available nutrients. And these don't even include the organic matter or the microbes, the sulfur, the calcium, the zinc, etc. And then the other thing that, this is harder in the States because your storages are bigger, but we have some storages that aren't that big. And if I look at a comparison of the same storage, but one is covered and one isn't covered. So 2,000 hogs, a 12 by 145 foot storage. So the capacity for manure is a lot of cubic feet. But the rainwater, which considers the evaporation, so I've done this using our MStore nutrient management software, but I've basically got 45,000 cubic feet of water that's accumulated from rainfall in that storage. So if I look at the days of storage, I've got a year's worth of storage here, I've got almost 500 days here. But my dry matter, more concentrated when I've got a covered storage. My nitrogen, phosphorus, and potash are more concentrated compared to the more watery one. And if I look at an average cost, this is Canadian dollars again, of $15 per 1,000 gallons of spreading manure, and I look at manure tanks that have 97% water, that's a lot of money spent taking water to a field. So in this case, and just in this example, I'm just on not having to take water to the field, I'm saving about $4,000. So my question to growers is, especially as they start looking at CAP funding, so here you've got H2 Ohio or something funding. Well, we have CAP, it's called Canada Agricultural Program or something like that, funding that's available to farmers. And so there's different things that they can do, including paying for organic amendments to improve soil. But how long would it take to pay for covering a storage? I don't know how much it costs. It depends on what type of style, but there are some people looking at that. And then even taking the solids out. So if we have high soil fertility levels and we don't need all that manure that we're producing, can we take the water out, have our liquid portion, our solid portion, and truck that solid portion to either fields farther from the home farm or selling it to neighbors or to somebody else? So it's easier to broker solid manure. Economics of storage is improved if we can take some of the solids out. And this is an example from, this was at the Manure Expo last year in Indiana. And it's kind of a cool system. Our neighbors have a screw press. That's probably cheaper. This again, I showed you this before. Just a little bit about cover crops. The synergy of cover crops with and without manure. 8-way mix, with manure, without manure. Pretty big difference in biomass. Pretty big difference in nutrient cycling and how much organic matter or carbon is going back. This was digestate with and without, or with oats, with and without digestate. This was cover crops with and without digestate, different mixes. But you can see that there's a pretty big response to those nutrients from manure. Approximately a third more biomass in most cases. And we found that with the multi-mixes, probably don't need to waste your money on 8 or 10-way mixes if you've got manure, because mostly it's the oilseed radish and the turnip that grow really big, and they shade out everything else. Another one that we did was we looked at anaerobic digestate. So anaerobic digestate, for those of you that aren't familiar with it, you take something that's like dairy manure, goes through the anaerobic digestion process, and you end up with something that's similar in composition to pig manure. Very close to pig manure. So here we applied oats, cover crop oats after wheat harvest, with and without this digestate. And what we did is we put that yield through the milk program to get an idea of what is the value of that as feed from a milk production perspective. Because you can talk about percentage difference in protein and percentage difference, but really what it comes down to is how much milk is produced from that additional cover crop and how much is taken up. And so you can see it's quite significant. It's just under $2,000 difference. But then the other thing we did is we looked at if we took that material and we put it all back in the soil. And so this is a way that we've looked at comparing it. If I only applied digestate, I would have to put on 200 applications of digestate to increase my organic matter by 1%. If I have just cover crop oats, I would have to do that about 26 times to increase my organic matter by 1%. If I have my cover crop oat and the digestate, that gets reduced to about 15 years. So there's a synergy of feeding that the cover crop with organic amendments, manure or whatever. This is the information that we got from Glenn. I saw this at the Manure Expo. There's some other people, some custom applicators that saw it. And with the extreme weather that we've had the last couple of spring seasons, it's been a really nice option to be able to go in and plant some corn and then go in and apply the manure afterwards. But the hard part was always, how long can you do it? And so when we saw Glenn's information that looked at how long can you go on with a drag hose and without impacting your population or your yield, that was great information. information where we can learn just as much from Ohio as what you can from us. And so that's a practice that's gaining momentum in Ontario, and I think we're going to see more and more of it. And the cadmium is made in Ontario. We do see some of it, but generally the fields in our area aren't long enough to make it. It's going to catch on slowly. I think the drag hose system is faster. Dairy solutions. Dairy farms have some options that other people don't have. Forage harvest, and in this case, you can see that there's still a row of forage here. They are harvesting the field and putting the manure on right behind it. They've got 2 of those dribble bar units from the Netherlands or from Europe, and they're putting that manure on right away. And they can do that after first cut, second cut, third cut, and in some cases fourth cut, if the weather permits. They're putting it on to a crop that's growing, a crop that needs those nutrients, not the ideal maybe 100% value from the nitrogen, but from a 4R growing season perspective, pretty nice way to handle manure. And one of the things that we've done over the time is we've looked at what is the impact on yield and quality from that manure that we put on forages. And we initially started that study to make sure that we weren't hurting the forage yield. But because when we look at applying into growing crops and applying to forages, well, we're applying the phosphorus and potash that crop removes. And believe it or not, a lot of our dairy farms have very low potash and phosphorus levels. Potash levels that are under 100 because they're just taking so much crop off. So they can't even, they probably still have to add some commercial. But the other one is spreading out the workload, reducing the compaction, and in this case, increasing yield. This is a busy slide, but what we did is we looked at from 2006 to 2012, 1 year missing because it was a bad year, but generally we had higher yield where we put manure compared to where we put just fertilizer, and especially where we had just a zero check. Then we put that into the milk program to look at quality and milk production, and again we've got anywhere up to 13% increase from manure. So we answered the question that yes, if we put that manure on at the right time, we are going to benefit the quality of that forage. One of the things that we found out with the manure in Ontario, ideal rates are between 3,000 and 4,000 gallons per acre. That's imperial gallons. It provides approximately 50, 45, 90 pounds of available NPK on average. But an analysis at the time of application lets us credit it back. This is too late. If we apply it this late, we've got too much regrowth. The tires are damaging the crowns. Those crowns have to start over, and we get a pretty big variation in that forage quality over the spread of the field. Ammonia loss is something that we had a couple of aha moments. So this is, we put dosimeter tubes. Anybody here done dosimeter tubes before? So dosimeter tubes are something that they use in chicken barns. And you can see from this tube, it starts out all pink, and then we put it onto a rebar about 8 inches from the soil. We put a pail on it. The pail has holes in it so that you get air movement. And then we come back and we look at the dosimeter tube every day. First day we do it a couple times a day. And you can see that as it's exposed to ammonia, that pink turns yellow. And so we're looking at relative differences between treatments. How much ammonia are we losing? And it depends a little bit on weather conditions as well. But we did one farm, it's a several year study. One farm went from dairy manure to anaerobic digestate. And so we said, okay, well, we'll do the same project with the digestate. And so we were putting the manure on, and I said to him, so you're going to get neighbors asking you what all these pails are about, because neighbors like to ask questions. And so we looked under the pail, and this anaerobic digestate, generally this is what you get after about 2 weeks. With the anaerobic digestate, we had this in 2 hours. And it was like, okay, what's going on here? It's because the digestate had a high pH. And when you get a pH that's 7.8 or higher, that ammonia volatilizes almost instantaneously. And so since then we've been doing a lot of pH work looking at pig manures, and it's all over the map. But if you've got pig manure and it's got a high pH and you think you're going to get nitrogen credit from it, but it's not incorporated for a day or two, chances are that nitrogen is gone. That was one of those aha moments that nobody thinks about that with digestate, but we really have to manage it differently. And so this is what it looked like just with the manure. This isn't including the anaerobic digestate, but you can see that where it's surface applied versus where it's incorporated or shallow injected, quite a bit of difference. But the pathway is the same regardless of when. So depending how hot it is, up to 2/3 of the ammonia in the first 24 hours. If we're using a splash plate and we've got a pooled area, a concentrated area, the ammonia volatilization is much higher there. So uniform application is ideal. And then rainfall after application tends to reduce the amount of ammonia volatilization. Probably you've heard this from Glenn many times. And then manure application to wheat. You don't have as much wheat here, but it's kind of a nice option. Most people, if they've got flat soils, flat land, they will put the manure on frost. So when we get those freeze-thaw days, it's -2 or something in overnight, and then it goes to +5. Oh no, sorry, Celsius. It's 30 or somewhere around 28 to 30 during the night, and then it goes up to 40 or 45 during the day. So it's that freeze-thaw. That's an ideal time to put it on flat soils, when there's not too much risk of rain. But we did one experiment where the wheat got a little bit higher than we wanted it to, and we thought, oh, is it going to come up? Are we going to ruin it? This is just an example of an airway. The manure is being applied in front of the airway. The teeth are in behind. We're going across the wheat field because this was plots. We did it with airway tines up, airway tines down. The tines actually did do a little bit of damage, took out some of the stand, but the results were the best where we had the airway tines up. You couldn't see where the drag hose had gone over it. You couldn't see any burn. It worked pretty nice. Could see a little bit of those wheel tracks, but the drag hose made no difference. So it was kind of the same question. How long can you do it before the wheat doesn't come back up? And this was a little bit more intensive study. We did several years of manure on wheat. And the recommendation was 2/3 manure, 1/3 fertilizer. Never 100% from the manure. And for a couple reasons. First of all, if it's dairy manure, you probably want less than 50, and probably with dairy manure you don't really want to do it, because the composition with dairy manure, we've got half of it as organic nitrogen, half as ammonia, where with pig manure we have about 80% as ammonia and a much smaller portion in organic. And so if you think about when wheat is growing, and Ontario is going to be colder than here even, we've got cold backwards conditions. We've got a crop that needs that nitrogen a month earlier than corn, but all our availability recommendations are based on that corn crop. So we really can't count on that application, that the microbiology being able to convert that nitrogen quick enough for that wheat crop to need it. So it's really important that we do have some commercial nitrogen with that manure. Works best with pig manure. It works pretty well with chicken manure, with broiler manure. Not as well with dairy manure, and definitely not with solid cattle manure. Protein, needless to say, you've got that slow release nitrogen from the organic portion, generally means that you've got a higher protein content. So if hard red wheat is what people grow, this is a good place for it. And then the last one I'm just going to talk about, and this is a kind of an out-of-the-box idea, but it's basically, we keep hearing about, oh, we're going to have regulations where you can't put on any phosphorus if you've got a soil test higher than X. And for us, it might well be 30 or 40 parts per million, who knows. So instead of that, people are looking at different ideas. And what if we could distribute the nutrients from areas of high fertility to areas of lower fertility. And so just basically, instead of the farmer doing all that planning, working with a consultant that does the planning, finds the neighbors that have wheat in the rotation, that have crop farms and need the nutrients. If you've got low soil fertility, you've just bought a farm, or you need to take it to even some of your own farms further from the storage, is there an opportunity if we look at valuing it differently? And then the opportunity for community storages. So in other words, I've got a farm that I rent from, or I've got a neighbor who's willing to build a storage so that he can use some of that manure. Are there opportunities like that? Are there opportunities like pipelines? Somebody talked about that earlier. Oh, you did this morning, that gas pipeline. Somebody actually did do that in Ontario. Built a pipeline, goes to the middle of the farm. They can take a drag hose and they can get a pretty wide distribution to a bunch of different neighbors and sell that manure. So there's some opportunities that we can look at, but it can't be the farmer that's doing all the planning because he just doesn't have time. It's never going to happen. How exactly the economics works, that's a work in progress still. I'm almost done. So this is what I'm talking about. If I have high fertility in my field, then it's going to take a long time before the phosphorus and the potash from that manure application becomes available. And so I might be, after application, let's look at finisher manure, I might be looking at just $6 worth of nitrogen value after application because it's going to take so long before that phosphorus and potash becomes available, and it might be an environmental threat. Whereas if I sell it to the neighbor like me, who has very low soil test levels, has to pay for NPK anyway, and I'm thinking, gee, I'll pay for the NPK because I'm going to get the microbes and the organic matter for free. Well, there's some bucks in the livestock farmer's pocket. He's not going to get use of those nutrients for years and years anyway. And so it's just a different way of looking at the situation. Poultry broilers, because it's dry manure, that makes the most sense because it's easier to transport farther away. But I think looking at this neighborhood nutrient planning is something that in Ontario we're looking at quite a bit more than years ago. And so just to summarize, manure and organic materials provide nutrients. They provide soil organic matter value. The 4R approach is going to provide the most economical nutrient utilization, minimize environmental risk of contamination. 4R approach is going to maximize application to growing crops because that's what the 4Rs stand for. And I think something to keep in mind, maximum value does not always mean maximum nutrients. We sometimes have to compromise for nitrogen, for labor, for soil quality in exchange for other farm priorities. So it's looking at what are the values of those different applications. And then just before I finish, I would like to just make everyone aware that the North America Manure Expo is going to be in Ontario this summer. It's going to be on August the 26th, the 27th. We have some fantastic tours. We've got a tour to the brand new dairy and brand new beef facility at Elora. They have a soil interpretive center with a whole bunch of soil measurements that they can do leaching, volatilization, all kinds of measurements. We have a tour to solid innovations, to liquid innovations, a dairy compost barn that's really cool, an agitator that's doesn't need agitation, it's airflow. We've got pit agitations, lots of good education sessions, and it's in an area of the province that has lots of nice parks. Stratford Theatre's near there. It's near London. So it's just outside of London at Listowel. Mark the date. Hopefully we'll see you there. Oops. Any questions? That was pretty close, right? 2 minutes to spare?
You're fine. Any questions at all for our Canadian manure girl? I see up there.
Yeah.
Doug?
Your organic matter thing, have you done that where you're specifically looking at change in organic matter where you had a soil that didn't have manure application for a while and now you do versus it's still being continuous crop?
Yes. We don't have a lot of them, but we have a couple. We did a compost study probably about 8-10 years ago, and one of our cooperators has continued to keep the checks in place, and then has, the Pioneer it's got the colors, the soil health map, forget what it's called. But anyway, you can see right to the row where the checks are. And that year, he had a 27 bushel yield advantage from where the areas that he had put compost versus the checks. It was a dry year. It was a sandy soil. It really showed that organic matter benefit. There's more of that that's happening on a large scale, like that chart I showed from the lab. We don't have that yet. Those are just samples that came into the lab. They've processed them by county, and we just took that information and don't know which ones were livestock farms, which ones were crop farms. It's just aggregate information. It'd be nice to do that, though.